Hello everyone and welcome to today's webinar. For those of you new to our webinars, I want to mention that audio is provided via the GoToWebinar application over the internet. Please enable your speaker in all places. The application has muted your microphone. This means that I cannot hear you. However, there is a questions tool at the right side of your screen. You can ask me a question at any time during the webinar and I will read and answer them aloud if time allows. If not, I will put together all the questions and answers in a document and send it out after the webinar. Today we are going to talk about safety requirement specifications and how you can use exSILentia to complete this important safety lifecycle task. But first, I should introduce myself. My name is Kate Hildenbrandt. I am product manager at exida for the exSILentia tool. So basically, I'm responsible for strategy, roadmap, and feature definition for the exSILentia software. I'm also focused on providing training and software support to our customers, our new and existing customers. And for this reason, I put my email address here on the slide. You can email me directly with any questions you have pertaining to this webinar or totally separate. A little overview of exida. We are a safety consulting company. This means that we do lifecycle services. We provide enterprise tools. Obviously, today we're talking about exSILentia. We also do certification and assessment of devices across the industry. We hope that all three of these together will basically help you achieve safety and optimize your work process when it comes to the safety lifecycle. We do have locations around the world, so hopefully you can find an exida professional near you to help you with anything you might need. So today we're going to talk about the SRS. We're going to start with what does IEC 61511 say about the SRS? How do you implement this using exSILentia? Then, how does the SRS or your requirements for your safety instrumented system change after you do your SIL verification? And then, obviously, we're going to summarize how you can do this all in exSILentia. So let's start with the standard. Let's go to the source. What does IEC 61511 say about the safety requirement specification? First, it defines it. It's going to contain functional requirements for the safety instrumented functions and their associated safety integrity levels. So it's going to basically communicate the design criteria of your safety instrumented functions for your entire safety instrumented system. And this is meant as a handoff between the analysis phase of the safety lifecycle, which includes your process hazard analysis, your layer of protection analysis, your SIL selection method, and therefore your design criteria. And so this is meant as a handoff of all that information to the design and implementation team. So let's dive a little bit deeper into that idea. We know the safety lifecycle pretty well, and usually you see it in the standard as a top-down list. However, it is a cycle, and so the data or the information that you're putting together throughout a project is going to flow from one task to the next. So first you start with your process hazard analysis. You're taking your complete system, you're taking your P&ID and breaking it down and brainstorming what could go wrong here. For high risk scenarios, you're going to continue on with the layer of protection analysis. Any safeguards that you define during your process hazard analysis are going to be layers of protection in your LOPA. And you're going to decide for each hazard scenario how much risk reduction is required to be implemented in your system. Based on that risk reduction factor, you might have safety instrumented functions as IPLs that result in a target SIL level or a target risk reduction factor. You can do this with the LOPA, you can use risk graph, you can use risk matrix, but eventually you're going to have a design criteria, your target SIL level that you need to communicate to the design team. All of this information is going to go into your safety requirement specification, but it doesn't stop with just your target SIL level. There are a number of requirements that the standard wants you to include so that you can hand off basically a usable document for the design team to use as a starting point. The general requirements for the SRS include that they want this document to be clear, precise, verifiable, maintainable, and feasible. So obviously, this can be actually used and helpful for the team that's going to design your safety instrumented system. Now, this is pretty hard to do: a clear, precise, verifiable, maintainable, and feasible. Usually this means you're going to need a repetitive work process, a streamlined way to do this. It also means all of the information in your analysis should be close at your fingertips. But what are the requirements that they want you to include? If you actually open the standard and you take a look, the requirements that need to be included in the SRS are extensive. I've included a screenshot of many of the requirements here. I'm not going to read through them for you, but you can take a look at the standard and see that there is a lot of information the design team is going to need to be able to complete the conceptual design. I will give you a high-level overview of some of these requirements. So for the hardware requirements, the standard wants you to document a description of all the SIFs needed to achieve the required functional safety, a tag list, a description of SIS process measurements, range, accuracy, and their trip points, the functional relationship between inputs and outputs, requirements for startup and restarting of the safety system, any interfaces between your SIS and your BPCS, your operators, etc., a description of any action needed to achieve or maintain safe state by the operator, and output states to avoid. So these are your hardware requirements only. And these are shown in section 10.3.2 of the standard. Moving on to software requirements. IEC 61511 wants you to include in the document real-time performance parameters, such as CPU capacity and network bandwidth, any program sequencing and time delays, equipment and operator interfaces, the action to be taken on bad process variables, monitoring of the logic solver, sensors, and final elements, and enabling proof testing and diagnostic testing of devices and application program. So again, this is just a handful of some of the requirements. Obviously, I showed you the screenshot. They are extensive, but this is a snapshot of what is needed in the Process SRS. There are obviously going to be requirements for each SIF. So you have your general SIF requirements, basically a description of the SIF, and of course that required SIL level, any failure modes and common cause failures, a definition of what the safe state is, the response time and the mean repair time, the maximum allowable spurious trip rate, so how often do you want your plant to have a spurious trip, energize or de-energize to trip criteria, demand source and demand rates, proof test intervals and implementation, and there's a lot here. And so that should give you a taste of all that is included in the safety requirements specification. It's obviously not just going to give you your target SIL. You need to understand how these SIFs will be implemented, how they will affect the plant, and how the design team should design them. So that's a lot. It's maybe a little bit overwhelming to start from scratch and try and write a document like this. And obviously, if you're starting from scratch, you might wonder how you're going to make it clear. You might wonder how it's going to be precise, verifiable, maintainable, and feasible. And on top of that, it might take a lot of time to complete the document. And so obviously, a simple, repeatable, streamlined work process is needed to properly document and communicate all of these requirements, but to do it project after project, hopefully in a way where the design team will know exactly where to find the information. And that is what exSILentia strives to do for you. So I'm going to go into how this would be implemented into exSILentia, and hopefully you can see how it might be easy to fulfill the requirements of the SRS. So again, here's our life cycle. Right now we're talking about the documentation of all of the analysis information you would need to design the safety instrumented system. And in exSILentia, we sometimes refer to this as the Process SRS. If you have the tool, it's just the SRS module, but it consists of two main categories. It has your generic requirements. So this is basically going to, on a high level, outline your purpose and scope statement, any references that you might need or the design team might need to understand better what's going on with the process. Any definitions, abbreviations needed, anything like that. So very high level. And then your SIS hardware requirements, your software requirements, and your generic SIF requirements. So if there's something that's consistent throughout all of your SIFs, you can fill that out once and apply it to each SIF. The other section is the SIF specific requirements. So even if there's consistencies throughout each SIF, I'm sure they're not all exactly the same. And so you have your SIF specific information as a separate section. Again, the generic SIF requirements can be applied to all at once to all of the SIFs, and then anything that doesn't apply can be overwritten in the SIF specific requirements. So let's take a look at what this looks like. Again, you're going to start with your high-level purpose and scope statement. This is going to start with general info. We have a bit of a default in the tool of a purpose and scope statement. However, I'm sure that you're going to want to go in there and customize it, and so that can be done right in the module. And this is sort of just a statement of what you're trying to achieve with the safety instrumented system based on your application. We then have references and standards. So here we have IEC 61508, 61511, ISA 84, all of the standards that might apply directly to your functional safety. You can add or delete these as needed. You can also put in references such as your P&ID, your bill of materials, anything like that that you might already have set for this. And then there's a list of definitions. We do have defaults for the definitions, but you can come in here and add or delete any definitions that you want included in the final report. Then you can move on to hardware requirements. So this is done via just a quick drop down. You can see at the top, requirement selection, select which section of the SRS to view, and you just select SIS logic solver hardware requirements. The first thing you're going to see is the SIL capability of the logic solver. So you can set that. And then you start to go through each requirement. Earlier I showed a screenshot of the standard and all of the bullet points and all of the requirements that it lists. Here, what you're going to see in exSILentia is basically a field for each requirement. Some of the language is very similar because we want you to realize that this is a template for a report, but it's also almost a checklist to say, yes, we've addressed each and every requirement in the standard. In some cases, we've added some extra things. You can leave them blank and they won't show up in the report, but obviously we want this to be a comprehensive document for the design team to follow. And so here with SIS logic solver failure requirements, you can see each of the requirements from the standard that need to be included. So action on logic solver fault detection, you have logic solver mean time to fail spurious, SIS output state combinations to avoid. The next section goes over interfaces to other systems. So obviously your engineering station, your BPCS, your operator station, any historians and other. SIS functional requirements, you have independent manual shutdown, major accident survivability. Operational requirements include startup and restart requirements. And here we have environmental extremes. So you can put in your ambient temperature, your humidity for your site, etc. And any notes are available there. So moving on to software requirements, again, this is very similar. It is a template that's going to outline for you each requirement for the software that the standard wants you to include in the document. So we have just a general description for application program, program sequencing, trip and time delays, process modes of operation. Then you have your real-time performance requirements, your CPU capacity, network bandwidth, etc. You have process variable validation, so low detection name, high detection name, low range, high range, and you can see the rest. I'm not going to read through each of them, but the idea here is that once you fill this into the template, it's going to automatically generate in the report. Hopefully, the design team will find this comprehensive way to have the information communicated, and then they'll always know sort of where to find that information they're looking for if you're consistently using this tool and generating the same report. We have proof test requirements here, and communication interfaces, application program failures. So you can see there all of the things that are included for the software requirements. Then we have general SIF information, and what we've included here are things that you might have consistent throughout your safety instrumented system for each SIF. So obviously the demand mode might be one of these, your operating modes, your manual shutdown, your protection method, description for that protection method, any trip reset, local remote, trip reset description, you have your mean repair time, your mission time, your major accident survivability. When you get into the failure requirements, you have your mean time to fail spurious, your sensor failure response, logic solver failure response, final element failure response, so on. For desired proof test intervals, you can set one for logic solver part, sensor part, and final element part separately. And then you have any override requirements. So you can see there you have your startup overrides, and then your voting degradation based on redundancy and your maintenance overrides. So in the tool, you hopefully just have to fill this out once. You apply it to all of your SIFs, and once you go into the SIF specific requirements, if you want to change it there, that's fine, but hopefully this is a bit of a time saver to say this is consistent throughout my safety instrumented system. Then you would go into each SIF and put in the SIF specific information. So this would include your SIF name and tag, what equipment you expect to be included. And I say expect for some of these things because obviously this is going to be handed off to the design team, and they're going to try and make sure that it achieves the target SIL level. So here you're putting in equipment you're expecting to be included in the SIF. What is the process safe state, the process safety time, your demand source, your demand rate. The demand rate is actually calculated from our LOPA tool if you're using it. So that is an automatic data transfer straight into the SRS. You have your demand mode, your operating modes, manual shutdown, so on and so forth. Again, some of this is going to match what was in your general SIF information. That might have been just transferred over from that section of the SRS. And obviously, hopefully then it would match. You have here sort of your intended legs. So we have a sensor leg, your final element leg. And then in the end, we have input-output functional relationship description, additional mitigation, related interlocks, any special requirements, regulatory requirements, etc. And so here you can see all the information you might put in for SIF specific. And again, you're going to have to do this for each SIF. Well, here it goes. There's more. Of course, you need your required risk reduction factor, your required SIL level, your SIL selection method. Here we have LOPA, but you can also do risk graph and risk matrix in the tool. You have your mean time to fail spurious, your sensor, logic solver, and final element failure response, your max restore time, max restore to service times, startup restart times, all of that information you're going to need. Again, here you have your sensor part and logic solver part, final element part, desired proof test intervals. You have override requirements, operational requirements, any environmental requirements for your site, and any reference documents that are relevant. Another cool thing that our SRS module has is if you have any custom data defined in the tool in your project configuration, you can apply that to your SRS, and so you can essentially create more fields if you want more included in the specification than we have here. And so that's one way you can customize it to make sure all of the information you need is included, but also that it's consistent throughout. And so those fields would show up just like these do under the heading of custom data, and that would be included in the report as well. So finally, when you've filled out the complete template, you have all the information you need, you can feel confident that you have all the information you need because each of the requirements has its own spot in the tool. Then you would generate your report. And what I'm going to do is I'm going to open up a sample report just to show you what it might look like. So when you go into exSILentia, this sort of report would be shown under the generate report. You can either generate report or export data in the tool, and this would just be your SRS report. It's basically going to show you exactly what you input into the tool. First, you have your table of contents. It's going to include your purpose and scope, your general SIS requirements, general SIF requirements, so on and so forth. So let's scroll through, and I'll go pretty slow. So obviously your purpose and scope is outlined in the first section of the tool that I showed is going to show here just in plain text. I'm showing this report to you in PDF format. However, it is generated in a Word format. So if there's anything here you see you want to change, you can do that. Obviously, it's more consistent to change it in the tool so that you don't have to be changing this every single time. Project to project, you might have to change it anyhow. Your general project information is included here. This is just a sample problem that I created, but you'll have your project identification, project name, and a description. Here, all the standards that are relevant are listed. We have 61511, 61508, and ISA 84. We also have a PNID here, and so you can input any project-specific references that you want to include, and those can actually be attached or linked into the tool. Well, the first section after that is going to be the general SIS requirements. So obviously this is going to go through the hardware and software requirements. This should look very familiar. Obviously we went through this in the screenshots, but it's going to start with that logic solver SIL capability. And it's basically going to address everything that you input into the template. So this is here are the software requirements. This is obviously an easy way to make sure everybody knows where the information is. Once you get used to the template, once you get used to the module, you should know exactly where everything is in the report. And hopefully the design team would also know where everything is in the report. Then you have your general SIF requirements. Again, this is a useful feature in the tool where you can basically set SIF defaults for your SIF specific requirements, but it's also listed here so that you know overall, you might have a mission time of 15 years for the entire safety instrument and system. You have your maximum response times for each SIF part. All of this is sort of default for your safety instrument and system, and so it's shown here in this section. And finally, you have your SIF specific information. I only have one SIF in my sample project to keep it simple, which also keeps this report pretty short, which is good for a webinar. But here you would have all of your SIFs listed. You'd have your required SIL, your required risk reduction factor, your SIF name and description. And so this is something, we split it up into low demand and high demand. I don't have any higher continuous demand SIFs, so You're not going to see any there, but if you have a number of SIFs, they're all going to be listed here with their high-level requirements and description. And then obviously it dives into the details for each SIF. So each SIF is going to be its own section. It's going to have its own table, and each table is going to be this standard table. So you have your SIF tag, your SIF name, your description, the equipment you expect to be included, so on and so forth. You can see your input information, your output information, your desired proof test intervals. So you see how this is very consistent with the module itself. And then finally at the end, you have your abbreviations and definitions that you want to include so that everybody is on the same page. And so that is your safety requirement specification. For one SIF, it's about 20 pages. So you could see how there's a lot of information included here, but it is addressing every single requirement that the standard wants you to address. And so this makes for a really streamlined situation. Obviously, if you're already doing the PHA, the LOPA, and your SIL selection in the tool, a lot of that information is already there. So you're not taking that and having to copy it into a Word document or copy it into another tool. It's just right there at your fingertips, which is nice when you're going to fill in some of this information. So that's the report that it would output. But that's not really where we stop with the subject of safety requirement specifications. And the reason is because eventually you're going to design your safety instrumented system. And that conceptual design has to be communicated to an implementation team, right? So how does the SRS change after SIL verification? So obviously, again, we know the Process SRS provides that handoff between analysis and design. Somebody is now going to determine if we're able to achieve our intended proof test intervals, if we're able to, obviously you need to achieve your target SIL and risk reduction factor, but how do we do it? So this obviously in SIL verification, when you finalize your conceptual design, you might have some things that change. So what could be impacted by SIL verification? Your proof test intervals, as I mentioned, the relationship between inputs and outputs, the need for redundancy. Sometimes you think you're going to have a simple SIF and you go in and you're not reaching your target SIL level. So you might need to add some redundancy. You might need to add more proof tests, so on and so forth. You get the idea. Any SIF level diagnostics, your mission time might change, your mean repair time might change. Once equipment is specified, you have basically set in stone your implementation requirements. So any equipment specific environmental restrictions, any mandatory maintenance activities can be specified here in the design phase. So what does SIL verification look like? First, we start with our sensor selection. I have a screenshot here of our version 4 exSILentia Silver module. And here you can see in the tree view off to the side, we're specifying our sensor part for my sample SIF. You're going to go through and name it. You're going to give it a description. You have group options, so the group vote, the mean repair time, and then now you're going to set up your proof test strategy. So we want just a proof test interval of 1 year. We have proof test coverage that is dependent upon the equipment that we select within the tool. You can say if your proof test is performed online. If so, is there alternative protection, and what is the duration of the proof test? You can have application level diagnostic tests as well. You can enable this within the tool, specify an interval, a duration, a coverage, and say if your diagnostic test is initiated automatically. Here it just says automatic, but you only would select that if it's initiated automatically. Then you're going to specify your legs. So you have a name, a description. For your sensors, your leg options include the measurement type. Here it's pressure. Your trip setting, is it high or low? Your transmitter fault direction, so if you have a problem with your transmitter, does it drive the signal over range or under range? Do you have external comparison? And if so, what is that comparison coverage factor? Then there's some PLC configuration options. If your transmitter is out of range, does the PLC detect that? Is there any transmitter fault filter? And do you trip on transmitter fault? So all of these selections can be decided here in the Silver tool, and they're obviously going to impact your results. Finally, you're going to select your equipment. Here we have a process connection and a sensor, and these are selected out of exida's SCRH database, so they have associated failure rates. They also have associated proof test coverages and proof test procedures. And so that is what it might look like if you're doing your SIL verification in the Silver tool for your sensors. It's pretty similar for your logic solver. You pick a logic solver out of the SCRH, or you can user define one. Here we have one out of the SCRH. You're going to determine or input the mean repair time, your proof test interval. The proof test coverage comes from the tool. But again, if it's performed online, you can put in that information. Same with any application level diagnostic tests. You can input that information there for if you're having one, what's the interval, what's the coverage. Here you can see that the tool is showing you the modules of the logic solver that are in use. So you have your main processor, your power supply, and then your input and output modules. So that is how you would specify your logic solver in the Silver tool. The final element is next. The group options are similar to the sensor. You're going to put in your voting, your mean repair time. You're going to define your proof test strategy the same way. You can put in partial valve stroke test, and here you can, once you enable that, you can specify basically which of the devices you're doing your partial valve stroke test to, and so that will affect your calculation. And then here you define your legs, you give them a name description, you give the leg option. So here is your valve open or close on trip. If it's closed, is tight shutoff required? And is your valve in severe service, or your final element? Finally, you specify the devices. Again, you can user define your device, or you can choose one out of the SCRH. Here we have a solenoid and an actuator valve combination. And again, this will automatically fill in your failure rates as well as any proof test coverages, proof test procedure, and so on. And so that is how we would specify our SIF. This is a simple SIF in the Silver tool. And obviously, we touched on a number of things, proof test strategies, actual equipment specified, any diagnostic tests, and so on. The tool is then going to spit out results. You see your required SIL and RRF and your achieved SIL and RRF. I did not achieve my requirements yet, and so I would have to keep on working, either adding redundancy or changing proof test strategy. For each part of the SIF, you have your sensor logic solver final element results for your risk reduction factor, for your PFD average, for your mean time to fail spurious. And then you have the overall results for the SIF shown there. For each contribution, you have your SIL according to PFD average, your SIL according to architectural constraints, and your SIL according to systematic capability. Your response time is shown, and your contribution from each part for the PFD average and your mean time to fail spurious. The tool will also show you your PFD charts, and so you can see how over time your probability of failure is affected by not only the failure rates, the mission time, but also the proof testing. And so that's one of the outputs of the Silver tool. So obviously, in the SRS that we talked about earlier, you are basically communicating requirements from analysis to design, but the design changes a few things, which means that you would want to communicate those changes out, but you might not want to change the actual document that you originally used. One of the reasons is that the Process SRS is sometimes a contractual document, and it might have been written by an entirely different group. So you might not want to go back and change that specific document. And for this need, we created in exSILentia what we call the Design SRS. So this combines the Process SRS requirements with your conceptual design defined in Silver to provide a single source of information for detailed design. And this is meant as a handoff between, again, design and the implementation team. So if we go back to our lifecycle, we see the Design SRS is here at the end of the design and implementation stage. So you have your SIL verification, you might weigh your costs when it comes to equipment, redundancy, proof test strategies, any routine maintenance, and then hopefully your conceptual design is set and you're going to communicate that out using the Design SRS. Now in exSILentia version 4, we have implemented the Design SRS, so it's going to look a lot like our Process SRS. The first section we have here is generic SIF information. And you can read through this. You could basically, again, fill all of this out as a default for your entire safety instrumented system. You press a button, it's applied to all of your SIFs, and then you can go through each specific SIF and override any information that doesn't apply. But you can see all of that there. Then for each part of your SIF, you have requirements that you want to document. So here you have the process connection for your sensor, any diagnostics, any start or restart requirements or interfaces. You want to document any environmental extremes, other special requirements, survivability, and then you see the multiple maintenance bypasses, other bypass information, maintenance override information, voting degradation, trip delays, and so on. And you might recognize that from the general SIF requirements. So some of these might just be filled out once and moved to the SIF. Obviously, you would want to review them to make sure they apply to this SIF. And then we have leg information. You have the sensor name, description. This would come right from the Silver module. You have the logic solver connection, your references, PNID number, model data sheet, your action, any comparison tags or maintenance overrides. One thing I couldn't fit in the screenshot was that you can also input auxiliary legs, auxiliary input parameters, and shutdown hierarchy for the sensors. And so here you have all of the information that isn't already defined in the Silver module for the sensors. You have sort of requirements that the implementation team needs to know. In the module, we're not going to make you fill out anything that you already defined in Silver. And so that information will be included in the final report, but it's not going to be shown here in the module. Similarly, for the logic solver, you have common cause sources, any diagnostics, unsafe process conditions. You have start and restart requirements. What are your interfaces? Do you have any environmental extremes in your application? And so on. And so here, again, all of the information needed for a Design SRS that are already defined in Silver don't need to be listed here. So this is all of the extras. And same goes for the final element. So this looks a lot like the sensor information filled in. You have process connection diagnostics, start and restart requirements, interfaces, environmental extremes, other requirements, survivability. We like to put in comments fields for you whenever we feel like it applies. Then we have the leg information, any resets, and again, you can input auxiliary output legs and auxiliary output parameters here. And that should all result in a standard report for your Design SRS. And again, I'm going to open that up to show it to you. And it should look a lot like the Process SRS, but it's going to include your conceptual design information. So I'll scroll through slowly. Table of contents is obviously going to be similar. We have a purpose and scope here as well. You have your general SIS requirements, your shutdown hierarchy, which you can define in the module. And then it jumps straight into general SIF design requirements. Again, this is your overall look at your safety instrumented system. Anything that's consistent throughout would be documented here. In the module, you can apply these to one SIF at a time or all SIFs at once. And then go in and fill out your SIF specific information. Much like the Process SRS, we're going to start the SIF specific information with a high-level SIF list. Again, my sample project has one measly SIF. You're obviously going to have a number here. It splits it up into low demand and high or continuous demand. And it's going to show your required SIL and RF, your achieved SIL and RF, and obviously a name and description for your SIF. And then it's going to dive into the SIF specific information. So here it's going to start with your SIF tag, SIF name. You can apply a group here. You can have a description. And then obviously your important results, the achieved SIL and achieved RF. You have any equipment here that actually ended up in the conceptual design. So here my SIF includes just the same equipment we hope for in the Process SRS, although that would need to change if I wanted to achieve my target SIL. We have the process safe state, process safety time, your demand source and demand rate, demand mode, operating modes, your manual shutdown, protection method, trip reset, response time for your SIF, maximum part response time, so you see it for sensor, logic solver, and final element, and your mission time. Then we have SIF failure requirements, vote to trip, vote channel to trip, fail close for each your sensor, logic solver, and final element. You have override requirements, operational requirements, environmental requirements for each SIF part, any specific ambient conditions for your site, and so on. Then you have your sensor part requirements. So this is going to take a deep dive into each part of the SIF. You have your voting, your MTTR, your leg information. Again, here for the sensor, it has transmitter fault direction. It has the fault filter. Does your PLC detect out of range signals? So again, that's information that you didn't input into the Design SRS module. You input those into Silver, and it's just bringing them into the report. Same goes for your proof test interval, your proof test coverage, proof test execution, so that would be duration, and so on. Then we have our additional requirements as documented in the Design SRS module, your maintenance override requirements, startup override requirements, trip delays, and so on. Then we dive into the logic solver requirements. Again, this is a combination of what you input into the Silver module and what you input into the Design SRS module. And finally, final element section, which looks a lot like your sensor section. And so again, the beauty of these reports is that everything that you put into the module is a requirement specified in the standard that you need to communicate to the next person in your work process. And so it's a template that, you know, is turn into a nice report here, but it's also a checklist that will make sure that you can feel confident that you've complied with this standard. Additionally, this one is meant to communicate everything you did in your design, and so a lot of that silver information is transferred over into this report. Again, we have a separate report for the design phase because we don't want to overwrite the process SRS. At times it's a conceptual document. So let's summarize this one more time. Process SRS is going to summarize all of your PHA, LOPA, SIL selection information, as well as all of the requirements from the standard. The Design SRS is basically confirming if you've reached your target SIL, target risk reduction factor, and any information needed for implementation. So once you determine your SIF architecture, your equipment selection, you're validating or changing your initial SRS requirements with a separate document. And so I hope that this was helpful in basically summarizing the requirements and showing how we would, with exSILentia, fulfill that need that the standard asks us to basically fulfill that task. And hopefully exSILentia would simplify that for you and create a streamlined work process. If you still feel overwhelmed by all of the requirements and you're still not sure how to carry out this task, exida does offer consulting services and on-the-job training for creation of SRS reports. So you can contact me, contact any of your exida contacts to see how we might be able to help you do this. But we're also hoping the tool makes it easier for you. If you want to know more about exSILentia, you can sign up for a free trial on exSILentia.com. If you want to know more about exida, you can follow us on Twitter at exida LLC for our latest news and upcoming conferences. You can also do this on LinkedIn and a couple other social media sites. If you want to get in contact with me, my email address is right here, phone number is right here. Again, I'm happy to answer any questions you have about exSILentia, exida at large, and obviously any SRS questions you have. That's it. Thank you for joining us. I hope that this was helpful for you. In the future, if you have any ideas for webinars, let us know. We'd be happy to take any subject you'd like to know more about and create a webinar. Thank you again for your help. Take care.